So hello, welcome back to this episode, or this video on a radiation heat transfer learning journal. So in the last video, we were talking about a little bit of complication with respect to our calculation of intensity. We saw that as from theta equals to 0 to 90 degrees, or 0 to pi by 2, the radiation I omega is actually starting from the bottom plate. And let's say for theta 90 to 180 or pi by 2 to pi, the radiation is coming from the top plate. So we kind of need to consider these two cases differently for this plane parallel case. And we see that the formula, while it kind of means the same thing physically, we see that this tau s, which is from here to here, is not this tau over cosine of theta, because now that cosine theta becomes negative, and then the whole thing suddenly doesn't really make sense. Okay, so the question is now, what do you want to do with this, right? What do you want to do with this? So this is what we want to kind of discuss in this video. And okay, so let's iron down some formulas. So we have two cases to consider. One from theta equals to 0 to pi by 2. And basically, the formula is more or less the same. Okay. Formula is more or less the same for the intensity. So, where is this? Okay. Yeah, formula is more or less the same for intensity. So I tau mu equals to blah blah blah. So to distinguish it, we call it I plus. Okay, we call this I plus because it's going from the bottom to the top. So this is basically radiation coming from the bottom plate going to the top plate. So in the increasing tau direction. Okay, so that's pretty straightforward, simple enough. Okay, so what about this second case? Because this is like more or less done already. It is finished. So what then do we do with this bottom case? Tau equals to pi by 2. I mean, theta equals to pi by 2 to theta equals to pi. Or you have this inequality here accordingly. So for starters, we will call this the I minus theta or tau mu. Alright. I minus tau mu. Okay, so that's how we kind of want to start. So we can take a look at this picture we have here and start a little derivation again. All right, so basically we want we do the same thing. Okay, we consider this length here, all right, this length over here, and the corresponding projection over here. So right, what do we then do? Okay, so we can consider this this length here, this optical thickness here, to be called tau L, which is the thickness of this medium. Since it's 1D, we can just conveniently have the thickness of the medium set to tau L. We just call it tau L. And this distance, right, this vertical distance, we just call it tau L minus tau. Alright, so the shortest distance from the top plate or top plane or top plate to wherever the point in question is, this distance is tau L minus tau. So that is the distance over here, which I have in red. This is this distance I'm talking about. So then we have tau s equals to, what is it? Okay, so tau s is equals to, where can we put? I'm going to use a slightly different color, maybe, no, another one pink. Let's see whether brown works. No, I need a light color. Okay, I'll try this color then. Okay, so we will have this, we'll just call it angle A, right? So accordingly, if we think about it, the distance is actually the length here is actually tau L minus tau over cosine of A. So we'll just write tau L minus tau over cosine A. So this, and we need to put the picture here. A is as shown in this diagram. Okay, so alright, A is shown in this diagram. Okay, so what is the relation between A and theta? So, right, remember, A is basically pi minus theta, right? A equals to pi minus theta, so cosine of A equals to cosine pi minus theta. Right, so this is how it kind of works. Okay. Now, what is the what's the relationship between cosine pi minus theta and cosine theta? Okay, cosine theta and cosine pi minus theta. So this is you have your trigonometry again. So if we take a look at a cosine graph, okay, so x, y, so let's put 0, 0 0.1, 0 0.2, okay, pi by 2 is about 6 pi is about 3.14, so I will have it somewhere here. So we have cosine of this. So let me, oops, wrong one. There we go. And let's put this graph here. Let's plot the simple graph. Yeah, so this is a cosine theta graph. Okay, so you can see at pi by 2, which is around here, you see that this graph, it basically has, okay, you have this kind of a reflection effect after pi by 2. So if you remember your trigonometry, and you should, so let me put this here. Now I'll just paste it as a picture. Okay, paste it as a picture. So if you can still remember your trigonometry, and I'll zoom in here. Okay, so you remember your trigonometry. Let me try and drag it up. Yeah, there's basically a reflection over here. I'll use a brown pen. There's a reflection over here at pi by 2, right? So what it's saying is that cosine theta equals the negative of cosine pi minus theta, right? Cosine theta is basically the negative of cosine pi minus theta, because right? Where is pi minus theta? So let's say you have 1. Let's say theta is 1. So this 1 will be some 0.6 something, right? And if you have 3.14, you minus 1, you get the around here. So this is the negative of this. So this is pi, right? This is pi minus theta. Yep, and this is theta. So, oh, sorry, this is theta. So if theta equals to 1, you see that pi minus theta, the cosine of pi minus theta is just the negative of theta. So, I mean, this is just a little reminder for us, and the graph is there so that you can convince yourself that it is indeed the case, right? Since you have Excel, just use it. Okay. So I have this picture here. So this is rather convenient for us, where we have cosine A equals to negative cosine theta. So we have that relationship there. Yeah, we have that relationship there. Okay. Okay, so what can we do? So if we have this yeah, if we have this, if this is theta, see you have this theta over here. If you want to put it in terms of theta, you can do it as such. Since cosine A is minus cosine theta, so I put minus cosine theta here. We have a tau L minus tau on top. And if we were to rewrite that, rewrite the top side, we can write tau minus tau L instead. So the top will be negative and the bottom will be just cosine of theta. So this is how we try and make the formula work. Okay, this is how we try and make the formula work for I minus. Okay, so if we want to take a look at I plus, this is the formula. So cosine theta is still mu. So wherever we find tau, we just replace it by tau minus tau L. Alright, so yeah, we can form an equivalent for I minus. Alright, so I minus is as such here. So we start with this, changing I minus here. What is next? We need to change the tau to tau minus tau L. Right? Everywhere we see tau, we just replace it by tau minus tau L. Okay. So tau S is a function of tau prime and mu, which is fine. Tau minus tau L will be here. And tau prime, how do we deal with tau prime? And how do we deal with this d tau over mu? So, yeah, so how do we deal with this d tau prime? So for that, we have to take a look again at this picture we are dealing with. Okay, I'm going to copy and paste this here once more. Alright, so let's enlarge it a little bit. Okay, wrong picture. I'll look for the other diagram. Oh, well, this is the correct diagram. Okay, then I'll scroll to this one then. Okay, okay, I think I might have copied the wrong picture over, but it's the right picture. Okay, so This I can just erase out. Okay, so yeah, how do we handle this tau prime? So what is tau prime or tau s prime? Tau s prime, it's coming from here. Tau s prime. That's what it physically means. And this will correspond to this distance here. And this distance here will be tau L minus tau prime. Okay? Yep, tau L minus tau prime. So what we have is tau prime will become tau L minus tau prime, right? However, of course, we need to take note to do these in terms of mu. So yeah, tau prime divided by mu, how does it become? What does it become? In the case of this I minus, we need to change it up a bit. So we will have tau prime minus tau L divided by mu. Alright, so wherever we see this tau prime, we need to replace it with tau prime minus tau L. Now for this s term, the explicit form of the function is not quite clear yet, so we can just leave this be. Where we need to take note, it is this tau prime here, where we need to have a tau prime minus tau L. Alright, and the other thing is that, okay, what about this d tau prime? So what about the tau prime? Alright, so what is this d tau prime? D tau prime is, or rather d tau prime over mu, that was originally, this was originally to describe d tau s prime, right? D tau s prime is this how this tau s actually changes. It describes how this tau s actually changes, and we need to integrate across this whole length. That's what the physical meaning is. So for a fixed mu, changing d tau prime will change d tau s prime. Alright, so yeah, when it's getting from this 0 to a positive number over here, so so we have that okay. So basically there needs to be some change of variable here. Oh, okay, I forgot. This 0 here, it should not be, 0 strictly speaking. This is when this 0 was from when tau prime equals 0 to tau prime equals to tau over mu. Okay. Yeah, so it starts from the tau being 0, or d tau prime over mu being 0 to d tau prime over mu being tau over mu. Okay, so the equivalent, this one is where tau equals to 0. Yep, so that means this one basically means from the point here, where tau equals to tau L. Tau equals to tau L to this point, which is tau minus tau L over mu, which is over here. Okay, this whole distance here. Okay, so okay, I'm gonna stop here for the time being. I'm gonna continue this discussion in the next video. So thanks for watching. I'll see you guys again. We'll try and discuss the proper change in variables, especially for this d tau prime. There maybe it can get a little confusing, but yeah, it should not be a problem in general. But yeah, we'll see you in the next video. Thanks for watching.